Have you ever wondered what happens when the most advanced engine in American history gets banned from every competition it enters, not because it's unsafe, but because nothing else on the planet can compete with it? Ford gave us the answer. To beat Chrysler's 426 Hemi after it swept the top 5 positions at the 1964 Daytona 500, Ford's engineers built an engine so technically sophisticated that NASCAR banned it before it turned a single competitive lap. NHRA banned it. Almost every sanctioning body with a rulebook banned it. The engine that Chrysler's teams refused to race against was eventually outlawed from the only competition it was built to win. What Ford created was the 427 single overhead cam, the Cammer, an engine that factory engineers rated at 616 horsepower, that independent testing suggested was producing considerably more than that, and that existed in so few street-legal examples that most automotive historians have spent decades debating exactly how many were built. This is the complete story of the engine that Ford built to beat everything, that was banned everywhere it tried to prove it could, and that disappeared before the world knew what it had lost. February 1964. Daytona International Speedway. Richard Petty put a Chrysler Plymouth on the pole at a speed 14 miles per hour faster than the previous track record. Not a small improvement, not a tuning advantage. 14 miles per hour faster than anything that had been done before on that track. Chrysler had arrived with the 426 Hemi, a hemispherically chambered V8 that had been developed in near-total secrecy through the early 1960s, while the company publicly maintained compliance with the AMA's ban on factory racing involvement. The hemispherical combustion chamber placed the spark plug at the center of a dome-shaped space, allowed larger valves to be positioned at wider angles than any wedgehead design permitted, and produced power numbers that were high enough to shock engineers from every other manufacturer when the Daytona qualifying times appeared. Chrysler swept the top 5 finishers in the race. Ford's best car finished 8th, not because of mechanical failure or driver error, because the Hemi was operating in a different category of performance than anything Ford had in competition. Ford's 427 FE engine, a legitimate piece of engineering that had won at Le Mans and dominated NHRA drag racing, was simply outclassed. The gap wasn't marginal, it was the kind of gap that makes engineers go home and start from scratch. Ford's engineers went home, and they started from scratch. The problem with the 427 FE in comparison to the Hemi was fundamentally one of breathing. The Hemi's cylinder head design moved more air per unit time than the FE's wedge heads could match. More air meant more fuel, which meant more combustion, which meant more power. The only way to match the Hemi's airflow advantage without adopting hemispherical chambers, which would have been a design project taking years, was to find a different approach to getting air into and out of the engine more efficiently. The overhead cam concept addressed this at the root of the problem. In a conventional pushrod engine, the camshaft sits in the engine block and operates each valve through a series of components, lifter, pushrod, rocker arm, that introduce mechanical mass and flex into the valve train. At high RPM, this mass becomes a limitation. Pushrods flex. Springs can't close valves fast enough. The valve train becomes the ceiling on how high the engine can safely rev, and that RPM ceiling limits how much power the engine can produce. Move the camshaft directly above the cylinder head, directly above the valves, and most of that mechanical chain disappears. The cam lobe acts on the valve through a very short, light mechanical path. The engine can rev higher, the valves can move faster, the air flows more efficiently at every point in the RPM range. This was not a new concept. European manufacturers had been building overhead cam engines for decades. What was new was applying it to a 427 cubic inch American V8 designed for superspeedway competition. Ford's engineers mounted a separate camshaft directly above each bank of cylinders, 2 camshafts total, hence the name Single Overhead Cam per Bank, or SOHC. The camshafts were driven by a timing chain that ran the full length of the engine, from the crankshaft at the bottom to both camshafts at the top. Keeping that chain accurate across the engine's full operating temperature range and RPM range was a significant engineering challenge, solved through a tensioner and guide system that maintained chain tension within acceptable tolerances at speeds up to 7,000 RPM. The theoretical ceiling was higher. Ford's engineers who worked on the program have described testing sessions where the camera turned 8,000 to 9,000 revolutions per minute in short bursts on the dyno. One recorded dyno pull reached 700 horsepower before the test engine experienced component failure. Not from the basic architecture failing, but from a specific part reaching its limit before the design as a whole had been fully optimized for that output level. The camera was an engine that the people who built it believed could produce more power than had ever been extracted from an American production-based V8. The factory rating was 616 horsepower with dual 4-barrel carburation, 2 Holley 4-barrel carburetors on a cross-ram intake manifold that fed the engine from both sides. This number, unlike most factory ratings of the era, was not a significant understatement. Ford's engineers were not trying to hide the camera's power output from insurance companies or class regulations. They were building it specifically for NASCAR, where power ratings were not a cost concern. 616 horsepower was approximately what the engine produced in its street-legal configuration. Race trim was another matter entirely. NASCAR's reaction to the camera was faster than the engine itself. The sanctioning body ruled the 427 SOHC ineligible for competition before it had turned a lap in any official event. The ruling was based on the same logic that had been used against the Hemi. The engine was not available in a production passenger car that any consumer could purchase. NASCAR's rules required that competition engines be derived from engines that appeared in regular production vehicles. The camera didn't qualify. Ford appealed. NASCAR held firm. The dispute became one of the proximate causes of the 1965 NASCAR season playing out without full factory participation from either Ford or Chrysler. Chrysler boycotting over the Hemi's ban, Ford threatening to boycott over the camera's ban, and the sanctioning body negotiating with 2 manufacturers simultaneously to prevent its Premier Series from running without factory cars. The settlement that brought Chrysler back for 1966 required the Hemi to be installed in 50 street-legal production vehicles. Ford got no equivalent deal for the Camry. The engine never received NASCAR approval, and Ford's factory NASCAR program eventually shifted focus to other platforms. The Camry would race, but not in NASCAR. NHRA's relationship with the Camry was more complicated. The sanctioning body initially banned it from competition in standard classes, reasoning similar to NASCAR's. Not a production engine, not eligible. But the drag racing world operated with different commercial pressures and a different tolerance for extreme engineering, and over time, the Camry found its place in special competition categories that existed specifically for exotic factory-supported experimental vehicles. Donald "Dyno" Don Nicholson was the central figure in the Camry's drag racing history. Nicholson had built his reputation tuning and racing high-performance Ford engines through the early 1960s, and his understanding of the Camry's requirements, specifically what combination of carburation, ignition timing, and gear ratios produced optimal quarter-mile performance, gave him a technical advantage over other racers who were still learning the engine's characteristics. Nicholson's Mercury Comet with a Camry under the hood ran times in the 10-second range at speeds above 130 miles per hour. Performance that, in 1965 and 1966, made it one of the quickest production-based vehicles in American drag racing regardless of class. The car became recognizable enough that Ford used it as a marketing tool, parking it at dealerships and featuring it in promotional materials that emphasized the connection between the racing program and Ford's engineering capability, even as the factory officially denied direct racing involvement. Gas Rhonda was another Camry campaigner of significance, running Galaxies and later Mustang-bodied competition vehicles to comparable times. The common thread in every successful camera drag racing program was the engine's ability to operate at RPM levels that production-based pushrod engines couldn't reach and couldn't sustain. The mechanical simplicity of the overhead cam arrangement, relative to its power output, also meant that camera engines were more durable at sustained high RPM than their pushrod competitors. They were fast, and they stayed fast across a full day of competition. Ford made the 427 SOHC available to the public not as a production option. They never cataloged it in a standard option list, but as a dealer-installed service part. A customer who wanted a camera in their Galaxy 500 or Fairlane could order the engine through a Ford dealership, have it installed, and drive it home on a legal registration. The practical process was more involved than ordering a standard engine option, requiring advance ordering and a dealership willing to perform the installation, but it was technically legitimate. The cost was approximately $2,000 to $2,500 for the engine alone in $1965, a significant sum that represented a substantial fraction of what the car itself cost. Total production estimates vary considerably. Ford's internal records have never provided a definitive count, and researchers examining dealer records and surviving vehicles have produced estimates ranging from around 50 to perhaps 100 complete engines delivered to customers in street-legal configurations. Whatever the actual number, it was small enough that camera-powered streetcars were immediately unusual and are now extraordinarily rare. Driving one was reportedly an experience unlike any other American V8 of the era. The engine made more noise, the overhead cam drive chain produced a mechanical whine that was immediately audible at idle. The power delivery was different from pushrod engines, coming on more gradually at lower RPM and then pulling with increasing urgency as the tachometer climbed. The engine wanted to rev, and drivers who kept it in the upper half of the RPM range found performance that was difficult to explain to anyone who hadn't experienced it. Ford's withdrawal from racing in 1970 ended the camera's competitive career. Without factory support and factory-backed teams developing the engine's tune, the competitive advantage that had made it exceptional in drag racing began to erode as other manufacturers' engines caught up in other ways. More efficient combustion chamber designs, improved carburation, better understanding of ignition timing across the RPM range. The camera was still capable of extraordinary performance, but it required expertise that was becoming concentrated in fewer and fewer hands as the factory backing disappeared. The street examples that survived faced the same pressures that affected all high-performance vehicles of the era. Emissions regulations, insurance costs, and the general collapse of the muscle car market in the early 1970s. Some camera engines were removed from their original vehicles and replaced with more emissions-compliant power plants. Some were rebuilt into competition-only configurations that removed them from the street-legal category. A small number survived intact in original vehicles, representing what may be the rarest factory-option engine configuration in American automotive history. The engineering principles the camera embodied eventually became universal. Every modern high-performance engine, every DOHC V8, every turbocharged inline-six, every naturally aspirated engine that produces specific power outputs that would have seemed impossible to a 1960s engineer, uses overhead cam architecture as its fundamental operating principle. Ford's engineers were not wrong about the advantage. They were simply ahead of a rulebook that took 60 years to catch up. NASCAR adopted overhead cam engines for the Gen 6 and next-gen cars beginning in the 2022 season, 58 years after banning the 427 SOHC from competition. The sanctioning body that outlawed Ford's most sophisticated racing engine eventually built its entire spec engine program around the technology it spent decades refusing to allow. The camera didn't disappear because it failed. It disappeared because the system it competed within couldn't accommodate it. That distinction matters. The engine Ford built to beat the Hemi was good enough to beat everything else on the track and threatening enough to be banned before it ever had the chance to prove it. The 50 to 100 street examples that exist today are not curiosities or mistakes. They are the only surviving evidence of what Ford's engineers understood about internal combustion in 1964 that the rest of the industry spent the next 3 decades figuring out.